Hi everyone, welcome to ATOMA 16. On our today's lesson, I'm going to explain how we are going to describe the type of sequences and what is sequence in general, is that? So sequence means this is an arrangement of numbers, is that? So arrangement of numbers is generally considered to be the sequence. So there are different kinds of sequence. So I'm going to explain how we are going to define and how we are going to find general or understand for these arbitrary sequences. So if you are a new member of my YouTube channel, don't forget to share, like and subscribe ATOMA 16. Well, now let's see how we are going to describe these different kind of sequences. So as you know, a sequence means it is an arrangement of numbers. That means if you got an arrangement of number, if you got a successive arrangement of numbers, between these numbers there must be some important relation. So we call this generally what sequence means. So let me explain the type of sequence that you're already familiar. Let me revise what sequence in general means. So there are different kind of sequence. So in the first case, I'm going to explain the type of sequences which is going to be arithmetic, geometric, and quadratic. Particularly today, I'm going to explain which kind of sequence is going to be arithmetic and which kind of sequences is going to be geometric and quadratic in general. So look, now let me define first of all. In general, a sequence A1, A2, dot dot, AN. How we are going to define this one? This is called in general an arbitrary sequence. A1, A2 up to AN is called 1. It is going to be arithmetic. Is that? This sequence is going to be arithmetic. This is an arithmetic sequence. Is that? It is going to be arithmetic. It is going to be an arithmetic sequence. It is going to be arithmetic if and only if the common difference between the terms should be the same. Common difference between terms should be the same. Means that A2 minus A1, A3 minus A2 is equal to A4 minus A3 is equal to dot 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 equal to AN minus 1, which is D. That's the element of real number. Is that? That means if the common difference between the term is always the same, means that when you subtract A1 from A2, A2 from A3, dot dot from AN to AN minus 1, if these values always the same, that is D, we call this is arithmetic sequence. Look this one. The difference of these equal to the difference of this one, and the difference of A2, A4 minus S3 is same. Is that? Means that if the first difference between the terms, we call this is first difference between terms. Is that? The first difference between terms. The first difference between terms is the same, means that now the sequence is absolutely arithmetic. Now this implies that the general or end stand for this kind of sequence is given by A1 plus D into N minus 1. So if the given sequence is arithmetic, it is a general term for the sequence is given by An is equal to A1 plus D into N minus 1. A1 means the first term, D means the common difference, and is simply end term for the sequence. So we call this is end or general term for the given sequence. Is that? So when you come to the second definition, this arbitrary sequence is going to be geometric. It is going to be geometric. When you say this sequence is geometric, it is going to be geometric sequence. Again, if and only if common ratio between terms should be the same. The common ratio between terms mean when we divide A2 for A1, A3 for its preceding A2, A4 divided by A3, its preceding is this one, which is equal to dot dot is equal to AN over AN minus 1. This is exactly R. If the common ratio between terms is exactly R, we call this is geometric sequence, and this implies that common ratio between terms. It means that when you divide the second for the first, the third for the second, the fourth for the third, the fifth for the fourth, if you divide these values and have the same ratio, we call this geometric. And if it is geometric, general term or n term for this is given by n, for this is given by a1 r n minus 1. Is that? This is generally how we are going to describe n or general term for a geometric sequence. Is that? If this is a geometric sequence, the general term for the geometric sequence is given by this is a1 times r raised n minus 1. Is that? So this is the first term, r is the common ratio, n is the n term for the sequence. So n is given by a1 times r raised n minus 1. So we call this geometric, and this is a general term for a geometric sequence. If the sequence is absolutely quadratic, it is going to be quadratic. Now the sequence is given, or it is going to be quadratic if and only if what? Second difference, the second difference between terms is the same. Is that? Same. That means if the second difference between terms is exactly the same, no, so we can record or we can just name the sequence is absolutely quadratic sequence. So you have to know how we are going to describe an arbitrary sequence. This one is arithmetic, geometric, and quadratic sequence. Let me give you simple examples about this one. Is that? Let me explain how we are going to say the following sequences are geometric or arithmetic or something like that. Is that? So let me give you now example. Let me explain with the example. For example, identify which of the following sequences, which of the following sequences are arithmetic, geometric, and quadratic sequence. Is that? Quadratic sequence. Let me explain how these sequences are arithmetic, geometric, quadratic, and neither. Is that? So let me give you now on the first A. Now the sequence, assume that we have this kind of sequence 2, 5, 7, 9 dot dot. Is that? And B, let it be 1 over 2, 1 over 4 dot dot. And C, this is 1, 4, 9, 25, and so on. Is that? So which of these sequences are absolutely arithmetic, geometric, and quadratic? And neither. Is that? So look, you have to know. For example, if you are asked to determine the 100th term for this sequence, the 10th term for this sequence, and the 20th term of this sequence, how could you determine general term for this? I think I have already given the partial or sum terms of the sequence. First of all, let you know what kind of sequence are these. Are these geometric, arithmetic, or quadratic, or neither of these one? First of all, let you know what kind of sequence are these. So let me explain. Now answer for this problem. For example, let's come to for the first problem. Is that? Now the first problem A, 2, 5, 7, 9. You have given this one. Is that? So what's the difference of the first? 5 minus this will be what? 2. What's the difference of 7 and 5? Which is 2. What's the difference of 9 and 7? Which is 2. So we call this is first difference of terms. Is that? Now this is the first difference between terms. Is that? We call this is first difference between terms. Is that? So if the first difference between terms of this sequence is the same, now we call this is generally what? We call this is arithmetic. Is that? That is what? It's arithmetic progression or arithmetic sequence. This is an arithmetic progression or an arithmetic sequence because the common difference between the terms is exactly the same. If it is arithmetic or arithmetic sequence or arithmetic progression, then you have to know what is the 20th term for the sequence. or the hundredth term for the sequence. If you are asked that way, first we need to find the general term. So the general term for, since it is an arithmetic, its general term will be what? An is equal to a1. A1 means which is 2. 2 plus d is, or is a common difference, 2. 2 into n minus 1. Is that? So this is exactly 2 plus what? 2n minus 2. This is cancelled by this one. So nth term for the sequence will be 2n. So what is the 20th term for the sequence? So if you are asked to find the 20th term for the sequence, you can immediately what? You can immediately just substitute in place of n, that is exactly 20 or something like that. Sorry, can we say that this is arithmetic? I'm sorry, I have made a mistake here for the calculation. Sorry for the calculation. Look the calculation. 5 minus 2 is 3. Not that is exactly 2. Is that? So because of this is not arithmetic. I'm sorry. This is not arithmetic sequence. Is that? This is an arithmetic. This is not an arithmetic. So if it is not an arithmetic sequence, what kind of sequence is it? Can you say this is geometric? So let's check. 5 divided by 2, 7 divided by 2. Common ratio is not the same. Still it is not geometric. It is not geometric progression. Now how we are going to check whether it is quadratic or not? Let's find the common difference, the second difference. 2 minus, let's find the second difference. This is -1 and the difference for this is 0. So -1, the second difference is not the same, and because of this is not again quadratic sequence or progression. Is that? So the first example, which is 2, 5, 7, 9, is neither of these sequence. Is that? It is not arithmetic, it is not geometric, if it is not quadratic sequence. It is not all of this. Is that? So now this kind of sequence is not arithmetic, geometric, and quadratic sequence. Let's come to second problem. For example, before just I directly come to B and C, let me change this problem. Assume that let it be 3. If it is 3, what kind of sequence is it? So let me check it again. Now if it is 3, what's the common difference between the terms? So answer for this problem will be what? Answer for this problem, you have 3, 5, 7, 9, and so on. Is that? So what's the common difference? The difference of this is exactly 2, and the difference is exactly 2, and the difference is exactly 2. So the first difference is always the same. Is that? If it is always the same, it is an arithmetic. Is that? Now it is an arithmetic. It is arithmetic progression. If it is an arithmetic progression, the general term for the sequence is given by a1. a1 is 3 plus d is 2, 2 into n minus 1, and which is given by 3 plus 2n minus 2, which is exactly 2n plus 1 will be nth term for the sequence. So the general term for these, or the nth term for this sequence is absolutely 2n plus 1. So if you want to know, for example, the 20s or the 100th term for the sequence, for example, what is the 10th term for this sequence? The 10th term mean, you know, this is the first term, this is the second term, this is the third term, this is the fourth term. The 10th term will be what? Now you have to directly, a 10 is exactly, in place of n you have to substitute 10. So a 10 is equal to what? A 10 is equal to 2 times 10 plus 1. Is that? Which is exactly what? 21 will be the 10th term for this sequence. So this is the way how we are going to determine some terms of the sequence based on the general or the quadratic formula. Is that? I mean, based on the general formula on nth term for the sequence. Is that? So now let's come to the first problem. On the second problem. When it comes to the second problem, can we say that the difference of this term is the same? I think it is not possible. It is not the same. 1 over 2 minus 1, 1 over 4 minus 1 over 2 will not be the same. So it is not an arithmetic. So let me check whether it is geometric or not. Now let's divide 1 over 2 for 2. Now 1 over 2 divided by 1 should be equal to 1 over 4 divided by 1 over 2. Then 1 over 2 divided by 1 is 1 over 2. And 1 over 4 divided by this is 1 over 4 times 2, which is 1 over 2. So it is the same. That means the common ratio between the term is exactly the same because of this. It is geometric sequence. If it is a geometric sequence, what will be the general term for this one? It is geometric. Now the sequence is what? The sequence is geometric progression or geometric sequence. If it's a geometric sequence, now Gn is given by, or you can say An or Gn, no problem. Now see geometric, An or Gn is given by A1. The first times are raised n minus 1. You know the first term is 1 and the common ratio is 1/2, which is n minus 1. So this is exactly 1 times any number itself. So this is given by 2 raised minus 1, the whole n minus 1. This is exactly 2 raised 1 minus n. So An for these geometric sequence is 1 minus n. Is that? So probably here on the problem, if you are asked to find the 100th term or the 20th or the 10th term for the sequence, now you can immediately what? Substitute 10 or 5 or 6. For example, what is the 5th term for the sequence? A5 is equal to 2 raised 1 minus 5, which is 2 raised minus 1, which is 1/16. Is that? The 5th term for this kind of sequence will be this one. So we can calculate nth term generally, the hundreds, the 1,000, 1 millions, any term for the sequence from the formula. Is that? Directly you can substitute the value, the 10th or the 5th or something term for the sequence with the formula. Is that? First, you need to know how to find n term for arithmetic, geometric sequence and quadratic sequence in general. Is that? So this is the way. Well, now let's come to the next problem. On the next problem, when you come to in the case of this one, the last question, which is 1, 4, 9, 25, and so on. What kind of sequence is it? First, let's find the difference of this one. What is the first difference, which is 3? What is this difference, 5? And what is the difference of this one? Again, the difference of this is going to be 16. Is that? Before this there is 16. Is that? There is 16, and you can continue 25, something like that. What the difference of this is exactly 7. Is that? So look, the first difference between this term is not the same. So let me check whether the second difference is the same or not. What's the difference of this one? Which is 2, because 5 minus 3 will be 2, and 7 minus 5 is again 2. So second difference between terms, second difference is the same. Is that? Second difference between terms is the same. If the second difference between the term is the same, now it is going to be quadratic. If it is quadratic, how we are going to determine general term for this sequence? What is the general term for the sequence? How we are going to find general term for the sequence of these terms in general? Is that? So that's the very important point. So please try to find the general term of this sequence. I think general term for this sequence is going to be n for the sequence is exactly n squared. Is that? N squared for this one. Now this is general term for the sequence. So I will explain how we are going to find the general term for this sequence in the next lesson. So thank you for watching. Bye bye. See you.